Hey everyone, welcome back to my channel EduVibe. So we will do the vitamin impulse. Today we'll start with another topic. So this is attraction in one dimension, but today we are focused on the attraction classification in the one dimension, where we have to learn the elastic collisions and the inelastic collisions, and the kinetic energy too. So let's start with kinetic energy first. So as you all know, GAD, what is kinetic energy? So when anything is in motion, when the object is in motion, so this is a kinetic energy. The energy associated with that motion is the kinetic energy. So we all know that kinetic energy is equal to half mv square. That ek is the kinetic energy in joules, mass in kgs, speed in meter per second. And kinetic energy is the scalar quantity, so their duration is irrelevant. So this always is in a scalar quantity that they don't have any duration. So we just have to calculate and calculate the magnitude. So elastic collisions. So in elastic collisions in a system, if the kinetic energy before an interaction is equal to the kinetic energy after an interaction, so this means it's known as elastic collisions. So the elastic collisions are like what they are if we have something in initial and after final, both kinetic energy should be equal, and that delta k is 0. But we have to just memorize this, that eki is equal to ekf. Final kinetic energy is equal to initial kinetic energy is equal to final kinetic energy. So if it is before, if it is after, both should be the same. Then we say that it is elastic collisions. In inelastic, there is opposite. So if the kinetic energy before interaction is not equal to a kinetic energy after interaction, this will be known as the inelastic collisions. So in inelastic collision, EKI is not equal to EKF. EKI is not equal to EKF, so we can say that EK is not equal to delta EK is not equal to 0. So before collision and after collision, both are different, both are not equal. So this main thing in inelastic that if two objects collide and they stick together, if they're a question and they're asking about there's a thing and that one object and two objects, they both collide and they stick. When they stick, ultimately it goes to inelastic collisions. So for only hit and stick, if there's a hit and stick collisions, so you can say that this is an inelastic collision. So we didn't find any kind of energy, we just say this is an inelastic. So let's move on to example. So the 0.5 kg ball rolls with a velocity of 3.0 meter per second. So you have a mass 1 and you have a v1i, which is in the right. So this is in positive. Towards 1.0 kg stationary ball. So this is the stationary ball, or this is now m2. The two balls collide, both are colliding. After the collision, that 0.50 ball rebounds with a velocity of 1.0 meter per second. So this is the v1f, is those left, so it's negative. And the 1.0 ball moves right with the speed of 2.0. So this is v2f. This is at the right. So this is stationary, so v1i is equal to 0 meter per second. Then we have to find that, what do you have to find? Okay, we have to find what type of system it is, elastic or inelastic. So for elastic and inelastic, we have to find the kinetic energy. There is no match, there is a hit tensor, this is the hit and rebound. So this means we have to find both. So for find both, we are just thinking about that EKI is equal to EKF, or they both are not equal. If they are equal, so this is elastic. So let's go with this. So EKI is equal to half m1 v1i square plus half m2 v2i square. So that v2i is 0. This is v2i. Is it 0? So this goes to 0. So I have to just find for this. Mass 1 is 0.50 and 3.0 scale. you get about 2.25 joules. Let's find the EKF. So M1 V1 final square of this, M2 V2 final square of that. So M1 is 0.5, this is 3.0 square, no, this is 1.0 square, M2 is 1.0, and this is 2.0 square. So you have to didn't like focus on the signs because this is a scare and this signs goes up when if it's scare. So it doesn't matter if you note on the sign or not. So when we calculate, we get about 2.25 joules. So you can see that our final and the initial was the same. So final initial was the same. So this means this is the last three collisions. So from A or from C, we have to know. So the measure momentum is conserved. No, in this, not the momentum is conserved. We find the kinetic energy, so kinetic energy is conserved and the momentum is also conserved. So for this, we do the C part. The C is the right one. That momentum and the energy are conserved and the collision is lasted for this because we get the same initial and final. So that's how you have to find the things are in this when we do deal with the last and elastic collisions. So this is more likely the easy topic and we'll do more questions when we do practice questions in the next video. So in the next lesson, we will do the practice question of the first half. So this is all the first half. We have to just carry over this first half to the second half to do it or more advanced now in two-dimensional now. So in the next lesson, we do some practice questions. Then we move on to the second half. So learning my simple EduVibe, learn smarter, not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.